This is a Innovate UK funded project with a company called Floating Energy Systems, which designed this. It's a hybrid platform, so it's somewhere between a spar buoy and a semi-submersible type foundation. The work we're doing here is looking at the hydrodynamic loads on the structure and the wave forces. This is an unusual design. It's designed so you have the spar, if you like, the large strut underneath, which is ballasted. That's hinged up, so it can be built in normal ports, so the draft is fairly low. So 8 to 10 meters draft, something like that, you can float it out, and then the spar, if you like, is swung down and locked into place.
The idea behind the physical model testing is to assess the displacement of the structure for the environmental condition, which are the wind and the waves acting on the structure. We want to assess if the structure will rotate or displace too much. The trouble is, if the structure will move too much around, the efficiency will drop, and on top of it can lead to a failure of the structure, and this is why these tests are really important. We are going to simulate 6 irregular wave conditions using our wave makers, and we are going to test 2 different configurations of mooring lines that were preliminary design. The other thing that we are testing here is the wind effect on the structure. Even if we cannot actually generate wind, we are going to simulate it with a system of string, pulleys and correspondent weight to be representative of the wind load on the superior part of the structure.
We've developed CFD modelling and also something called OpenFast, which is a much quicker method of looking at hydrodynamic forces. And the idea is we can develop those models and then calibrate them using the physical modelling. And then when we go forward, we can then, rather than having to redo the physical modelling each time we scale up to a different prototype size, we've already got a calibrated numerical models we can then use to calculate the forces for larger scale turbines. The work we're doing here in the Stinger Keel to develop this toolbox, if you like, this CFD and numerical modelling toolbox, is going to be really important for any other designs that need to be tested, because as well as the tank tests, you need the numerical models to go along with the tank tests. One of the advantages of testing in the fast flow facility is, as well as having the very close access, the windows where we can see what's going on, we're also able to empty and fill the basin very quickly. So it's very efficient in terms of doing lots of tests. We can empty the basin, we can go in, make the changes, and then we can refill the basin within a few hours. The next phase for the Stinger Keel is the main structural design, is to get that right. And then they're looking at the fabrication design and then look at properly costing it. And then the next stage will obviously be build a full-scale prototype.
I find it really challenging, first of all, because it's quite innovative, something that has never been done before, or I would say not at this level maybe of details. I feel that I can be part of something big that is our challenge to change our source of energy. So yes, I'm really happy and proud of being part of this project.